Chapter 1, Section 5A. We're talking about complex numbers. How many of you have heard, not that you know or anything, but heard about imaginary numbers? Seen them. Okay. All right. It's very, very similar, guys, to adding, subtracting, and multiplying when you have a variable. That's how we're going to treat it, okay? What you need to know, you need to know that the value of the square root of -1 is I. All right, we need to know that. You guys need to commit that to your memory. Some of you are like, what are you talking about? Okay, we've dealt with real numbers. Up until now, if you guys had the square root of a negative number, we said no real solution, which is true. You cannot physically graph on an XY plane a negative underneath the radical. But you can get a solution. It's just imaginary. What it means is it doesn't cross the x-axis, but it is a solution. So once you guys get to polynomials that have to the third and fourth power, you'll have maybe 4 answers, but only 2 of them will be real. We'll get to that later on. But we're now just going to get to the concept of imaginary numbers. Another thing you need to understand is that the value of I squared is -1. Okay? We're going to get into breaking them down and stuff a little bit later next week, but I want to just discuss how to add, subtract, multiply, and divide today. What you need to remember, 100,000,000%, I'm going to say this probably 15 times today. When you see I squared, you're going to cross it off and change the sign in front. I'm going to keep saying that. You'll see what that means in a second. Okay? A lot of times you guys are going to see the directions say write your answer in standard form. You've seen that before. What that means is your variable's descending. When they ask you to write it in standard A plus BI, A is the real part. A is the real part, and BI is the imaginary part. How can you differentiate the two? What does the imaginary part have? It has an I. Like, you're going to have, it's going to say write your answer in standard form. That means the real part of the number goes first, the imaginary part goes second. That's what makes up a complex number. So let's look at this right here. How would you write this in standard form? Well, what's real? The 2, right? So I write my 2. And I want you guys to get in the habit, because you're going to have to break down radicals, do all the stuff we've been doing, but it's going to be negative. I want you to separate this as to -1 times 25. Because if you answer the square root of -25 is 5, that answer is completely wrong. It's not like, oh, close. It's wrong, because you're telling me it's real when it's really imaginary. So separate the -1 with the number so you remind yourself, oh, there should be an I attached to this. So the way that you should look at it is you have your 2 plus, what is the square root of 25? 5, so that comes out, right? What is the square root of -1? I. That is your answer. If you do not include the I, it's like super duper majorly wrong. So make sure you guys are just paying attention. Yes? No, because you didn't physically take the square root. That's a good question. If it's already written, they're just asking you for how it's written. If you physically put the square root on, that's when plus or minus goes in front of your answer. But this is your complex number. This is the A part. This is the BI. The real part goes first. The imaginary part goes second. So let's just go through a couple little examples on how to add, subtract, and multiply. Then we'll get to division in a second. You guys are going to be perfectly fine. All right, this is just like you could treat I like it's a variable. What do we need to remember? When I see I squared, I'm going to do what? Cross it off and change the sign. It stands for -1, but you'll see why I just say cross it off, change the sign. What are we doing right here in number 1? You're adding, okay? Don't make this any harder than you need to. You're adding. Real goes with real. So 4 plus 1 is what? 5. What's 7i minus 6i plus I? That's it. Just if that was an x, you wouldn't say 5 plus x becomes 5x. You just, the real part stays with the real, the imaginary stays with the imaginary. What are we doing in 2? We're adding again. Okay, so real with real. 1 plus 3 is 4. What happens with a positive 2i and a negative 2i? It cancels out. So you're just left with the whole number 4. But if you were to write that in standard form, it would be plus what? 0i. WebAssign might want it like that. Read the directions. Whatever it says, write it in standard form. Write it in standard form. All right, what do we have to do with 3 before we can start combining? We got to distribute, guys. This is why I've been harping on you about signs and distribution and stuff like that, because as the concepts get more involved, those little mistakes make bigger problems. So I have 3i out in front here. What's a negative and a negative? Okay, so plus 2, then what? Minus 3i. Minus 2, what? Minus 5i. Okay, perfect. Now can we combine like terms? Okay, real with real. So I have positive 2 and a negative 2. What happens? That cancels out, so that's 0, real stuff. What's 3i minus 3i? It cancels, and then you're left with what? Minus 5i. There you go. Write it like that in standard form for now. And then read the directions on what it says. Yeah.
Why would you not put 0 plus 0i plus, or minus 5i? That was 8.
Okay. No, you have, the real part has to go first. All right, what do I have to do here before I can start adding? I got to distribute. Remind yourself, so it's 3 plus 2i plus 4 minus I minus 7 minus I, right? Real with real, so 3 plus 4. Anybody? Okay, thank you. 7, and then minus 7. It can't, it's 0, okay? What's 2i minus I? And minus I. It cancels. So everything just cancels. Your answer here is 0, guys, but if they ask you to write it in complex standard form, you have to make sure that you have something for the real part, something for the imaginary. Just showing you. All right, let's go to 5. What are we doing in 5? We're distributing. Do the rules of math change? Absolutely not. Multiply. 4 times negative 2. Negative 8. 4 times 3i. Plus 12i. Can I combine those two? No. Is it written in standard form? Yes. You're good to go. All right. Here's where you have to remember, when you see an I squared, what do? Cross it off and change the sign. I'll show you why. I'm going to show you why one time, and then we're just going to do what I said, cross it off and change it. Guys, we're foiling here. Do you understand that? You have 2 binomials stuck together. Math doesn't change. 2 times 4 is 8. 2 times 3i plus 6i. Negative I times 4 minus 4i. Good. And then negative I times 3i. Negative 3i what? Squared. You'll never, ever, ever have an I squared in your answer. What does I squared represent? It represents negative 1, right? That's what the value is. So if I have a negative 3 times a negative 1, what does that become? Positive 3. That's why I say get into the habit of when you see I squared, and I'm going to say this a million times today, I have I squared. As soon as I see I squared, I go, uh-oh, I cross it off, and I do what to the sign? I change the sign. Now it becomes real. So you can add real with real. What's 8 plus 3? 11. And then what's 6i minus 4i? Plus 2i. There you go. That will happen every single time we FOIL. All right. What do you guys notice about 7? Look at the 2 parentheses. What do you notice? Okay, difference of perfect squares. I'm glad you guys said that. These are conjugates of each other, opposites, right? You guys have seen complex, you've seen conjugates. Like if we had 3 plus the square root of 2 in a denominator, are we allowed to have that? So we multiplied by what? 3 minus radical 2. Well, you're not allowed to have a radical in the denominator. What do you think you're not allowed to have in this case in a denominator? Can't have imaginaries. So in a second, when we do division, you're going to have to multiply the denominator by the conjugate. It's super easy. It's the same thing as you guys have done before. You just change the sign in the middle, because watch what's going to happen. When I multiply 3 times 3, I get 9. 3 times negative 2i minus 6i. 2i times 3 plus 6i. 2i times negative 2i. Negative 4i squared. Uh-oh, I see an I squared. What do? Cross it off, change the sign. Now what happens, guys, with negative 6i and positive 6i? They cancel out. So do I have any i's left over? No. We're going to need that when we do our division. So it's 13 plus what? 0i. Good. It depends on what the directions say, and I'll talk to them and see like how strict we want to be with it. But for right now, I want you to understand that there's two pieces to just kind of get it in your mind that the real part's first, the imaginary part's second. All right, what does 8 say? I have 3 plus 2i. How many times? 2 times. Are my middle terms going to cancel out here, guys? No. But the math is still the same as we just did on our factoring test. What's 3 times 3? 9. What's 3 times 2i? 6i. What's 2i times 3? 6i. What's 2i times 2i? Plus 4i squared. Uh-oh, I see an I squared. What do? Cross it off and change the sign. Good. So this becomes 9 minus 4, which is 5. Yeah? And then what is 6i plus 6i? Can I combine anymore? No. There you go. Questions? Comments? Concerns? Yeah.
If the coefficients are both divisible by the same number.
We'll talk about that in a minute. You don't have to factor here. Like if you had 6 plus 12i, just leave it. You don't have to factor. But when we get to the division, we're going to have to simplify. All right, what are we doing here? Adding, subtracting, or multiplying? We're multiplying. Why are we hesitating, guys? It's 2 parentheses stuck together. 2 times 3 is 6. 2 times 3i. Okay, plus 6i. Negative 4i times 3. Negative 12i, good. And then negative 4i times 3i. Minus 12i squared. As soon as I see I squared, I do what? Cross it off and change the sign. So real with real. What's 6 plus 12? 18. And it's positive 6i minus 12i. Minus 6i. Very good. Very good. Is this terrible? No. Got to be careful. So. All right, I already talked about this. You guys already know this. When we are dividing, you have to multiply the denominator by the complex conjugate because you can't have i's in the denominator. And you guys are like, okay, we already know what conjugates are. Complex because it has an a real part, and an imaginary part. That's why it's called a complex conjugate. But you're going to have the same numbers, just different signs in the middle. And when you multiply the complex conjugate, what happens to the middle term? It'll cancel. So you'll have your I squared, and then it's like, oh, I squared negative 1, the middle term's canceled, then you're left with a real number in the bottom. So let's just talk about these two conjugates right here. What would the conjugate be, complex conjugate of 1 plus I? So I'm going to multiply these two together. FOIL, 1 times 1 is 1. 1 times negative I, negative I. 1 times I is plus I. I times I is negative I squared, correct? I see I squared, I cross it off, and I change the sign. Well, what number's left there? There's a 1. So what happens to my i's in the middle? They cancel, which is exactly what we needed to happen. So 1 plus 1 is what? 2. Don't worry about writing the 0i, because when you're multiplying by the conjugate for denominators, you don't need that. That's just when you're simplifying. So what's the complex conjugate here for 4 minus 3i? 4 plus 3i. Perfect. So FOIL. 4 times 4 is 16. 4 times 3i. Negative 3i times 4. Minus 12i. Negative 3i and positive 3i. Minus 9i what? Squared. I see I squared. What do? Cross it off and change the sign. So real with real. What's 16 plus 9? 25. And what happens to your 12 i's? They cancel. Good job. Good job. Good job. Good job. So now we're going to talk about dividing, and then we'll be done. Denominators must be rationalized. Write this down. Write this down. Write this down. No i's in denominator. How many times did we talk about no radicals in the denominator? You guys kept leaving radicals. You cannot, should not ever have an I in your denominator. If you turn your quiz in and you have I's in the denominator, just know I did something wrong. I don't know, maybe not, you didn't know where you went wrong, but you did something wrong. To rationalize, you're going to multiply by the complex conjugate. We're going to go through these examples, and then we'll be finito. All right, what is the problem in number 12? What's the issue? I in the denominator. So we need to say, oh, I got to get it out. So I'm going to multiply by the what? Complex conjugate. What's the complex conjugate of 1 minus I? Perfect. So if I multiply the bottom, I got to be fair. If I multiply the bottom of a denominator, I have to do what? Multiply the top. I always simplify the denominator first, guys, because I just check to make sure I'm multiplying by the correct thing so the i's will cancel out. This is a good way to check if you made a mistake. Maybe you forgot and you multiplied by the same thing, and then you realize, oh wait, the i's didn't cancel, I did something wrong. So we have 1 times 1 is 1. 1 times I is plus I. Negative I times 1, negative I. And what's negative I times I? Negative I squared. Uh-oh, I see I squared. What do? Cross it off and change the sign. Well, what number is left there? There's a 1, okay? So what happens, guys, with my i's? Positive I and a negative I. They cancel, and I'm left with 1 plus 1 is 2. Did the i's in the denominator disappear? Yes, so then what we needed to happen happened. So now let's distribute on the top. What's 4 times 1? 4. And what's 4 times I? So you're left with 4 plus 4i. What do you think I have to do here? You have to simplify. The easiest thing to do, you can definitely split it up if you want to. Put 4 over 2 plus 4i over 2. But what I would do is just factor out the GCF. What's in the numerator that is the same in both terms? What can we take out of both? We can take out a 2? Okay. So I'm left with 2 plus 2i over 2. You can take out a 4. That's fine. Okay, look, if you take out a 4, that's fine. You're left with 1 plus I over 2. But what would you simplify? Okay, so you would be left with 2 times 1 plus I, or if I did it like this, I'd be left with what? 2 plus 2i. These two are the same thing. I just simplified to get rid of the denominator. Either way, that's fine. But you have to simplify. If both terms have something in common that you can take out, you have to simplify. So every time, I would just take out the GCF from the numerator and then simplify it with the denominator. Then you can leave your answer like this or like this. Yeah.
Since, and then like that one on the left, since there's a 2 in the numerator and the denominator, wouldn't they like 2 over 2 equals 1?
How, like where?
Like there, so it's like 2 parentheses I, 1 is I, and there's like a 2 in the denominator.
The 2's, you divided the 2 out here.
Oh, okay.
Yeah, that's where you simplified. Uh-huh.
When the i's canceling each other out in the denominator,
Mm-hmm.
since the last I is a plus, wouldn't there be still an I remaining?
No, because it's plus 1. I squared is equal to negative 1, and there was a minus sign there, so minus a negative gives you a plus. This value turned into a real positive 1, not an I. All right, 13. Where is the issue? Where does the issue lie? In the denominator. So what do I have to multiply the top and bottom by? 1 minus I. Good. Don't get confused because these look similar. The denominator is your issue that you have to finish. You got to fix first. So 1 times 1 is 1. 1 times negative I, negative I. I times 1 plus I. I times negative I is negative I squared. I see I squared and I do what? Cross it off and change the sign, right? So what is left there? God bless you. A positive 1. So now, guys, what can I do with my i's in the middle? You cancel them, and then I have 1 plus 1 is 2. Cool. All right, let's go to the top. 1 times 1 is 1. 1 times negative I is negative I. Negative I times 1, negative I. What's negative I times negative I? Plus I squared. As soon as I see I squared, what do? I cross it off and I change the sign. So what's left there? A negative 1. All right, so we combine like terms, guys. What's 1 minus 1? 0. And then I have a negative I, and a negative I gives me negative 2I. Can I simplify?
You have to have a 0 in front of you.
You can if you want to. You don't have to though with division. But what can we cancel? Okay, because 0 over 2 is just 0, right? And then what can I do with the 2's? So you're left with just negative I. If you want to write 0 minus I, you can, but you don't have to. You probably won't see a problem that works like that. It's just to show you that sometimes your real parts can cancel out and you're left with just imaginaries. But where does the imaginary have to be? Got to be on the top. It cannot be in the denominator. The problems you will see are like 14, 15, and 16. And if you miss that first step, then the whole problem is wrong. What is the first step to simplifying this problem? Multiplying what? 4 plus 2I. To where? The bottom and the top. You've got to multiply by the complex conjugate of the denominator. So go ahead, simplify your denominator first to make sure your i's cancel. 4 times 4 is 16. 4 times 2I plus 8I. Negative 2 times 4I minus 8I. And then negative 2 and a positive 2I. Minus what? 4I squared. As soon as you see that I squared, what do? Cross it off and change the sign. Make sure you guys do that every single time. So now what happens here, guys? Real with real. 16 plus 4 is 20. Good. And then what happens with positive 8I and a negative 8I? They cancel. So it's exactly what we needed to happen. Did it happen? Yes. All right, so let's go to the numerator. What's 2 times 4? 8. You guys see that? Yeah. What's 2 times 2I?
4.
Plus 4I. Great. What's 3I times 4? 12I. And then what's 3I times 2I? Plus 6I squared. As soon as I see that I squared, what do? Cross it off and cross it off and what? Change the sign. So real with real. What's 8 minus 6? 2. And then what's 4I and 12I? Plus 16I. Is there anything that the numerator and the denominator have in common? A 2. If I factor out a 2, I'm left with 1 plus 8I, correct? Over 20.
Over 10.
Well, I haven't divided yet. I just brought the 2 out in front, right? And I have over 20. So when I simplify, what happens? 2 goes into 2 once. 2 goes into 20 10 times. So 1 plus 8I over 10. Somebody last period said, can't you simplify that more? Yes, you can, but you don't have to because the entire thing doesn't simplify. If you broke it apart, what would it be?
1 over 10.
1 over 10 plus, 4I over 5. You do not have to do that. If you want to, that's fine. On a multiple choice test, if you ever saw this on a standardized test, or if we decided to do multiple choice for anything, that might be an answer choice you need to recognize. Yeah.
So we divide it by 2. Why do we divide it by 2?
Because you always simplify fractions.
Because we simplify the numerator or both?
You have to simplify your fraction completely. So what this fraction says here is 2 over 20 plus 16I over 20. They're just 2 fractions, right? So you have to simplify. You don't have to simplify separately. You can just simplify the whole thing as a whole. So you take out the term that they have in common, the GCF. What does 2 and 16 both have in common? 2. So we brought that out in front here. And then you can simplify with the denominator then.
Okay.
But you have to simplify. Yeah.
You said the 1 over 10 plus 4I over 5 is fine.
Yeah.
Okay.
Yeah. All right, let's do the last two and then we're done. Where does the problem lie here? Where's the issue? In the denominator. So I'm going to multiply by the complex conjugate, which is 5 plus I. What you do to the bottom, you do where? To the top. I recognize that I am repeating myself every single time because I want you guys to see this process does not change. You do the same thing every time. Let's simplify the denominator first. Make sure our i's cancel. 5 times 5 is 25. Good. 5 times positive I plus 5i. Negative I times 5, negative 5i. And then negative I, positive I, minus I squared. As soon as I see that I squared, I do what? Cross it off and change the sign. If there's no number there, what do I put? A 1. What happens to my positive and 5i in the denominator? They cancel. Perfect. So I have 25 plus 1 is 26, which is exactly what we wanted to happen. So good job. Now simplify the numerator. 3 times 5 is 15. 3 times I is plus 3i. 2i times 5 plus 10i. Excuse me. 2i times I plus 2i squared. As soon as I see that I squared, what do? Cross it off and change the sign. Okay, so real goes with real. What's 15 minus 2? 13. Oh, that doesn't look like a 3. 13, good. And then positive 3i and a positive 10i. Plus 13i. Is there anything in the numerator that's a GCF that they both have in common? 13. If I factor out a 13, I'm left with 1 plus I, correct? Over 26. And then can you simplify out here 13 and 26? Yeah, 13 goes into 13 one time. 13 goes into 26 two times. So it's 1 plus I over 2. If you wanted to write 1/2 over I plus 2, perfectly fine. I'm not sure how WebAssign wants it. They might want it like this, just like they did the quadratic. So figure that out. Don't send me an email like, my WebAssign doesn't work, keeps marking it wrong. You guys are getting the hang of it. All right, let's do the last one and then we're finito. Where does the problem lie? In the denominator, right? These are very similar. The numerator and the denominator are similar. Do not get yourself confused. We look at the denominator and we have to multiply by the, what do we call it? Complex conjugate. Good. What's the complex conjugate of 4 plus 3i? So I'm going to multiply the bottom by the top. Are you guys, are you sitting here like, oh my gosh, she's just not stopping? I'm not going to. It's my job to be super math annoying for you. You're welcome. Denominators, 4 times 4. 16, good. 4 times negative 3i. Negative 12i. 3i times 4 plus 12i. 3i times negative 3i. Negative 9i squared. What do I do with this I squared? Cross it off and change the sign. Do you guys see the importance? How I've been harping on you about signs and paying attention and being neat. We miss a little sign, we have a big issue here. So I'm going to multiply. I got it. I'm going to simplify. My negative and positive 12i's cancel. And then I'm left with 16 plus 9, which is 25. Perfect. My I has left the denominator. It's exactly what we needed. So now I'm going to go back up and work on my numerator. What is 4 times 4? 16. 4 times negative 3i, negative 12i. Negative 3i and 4, negative 12i. Negative 3i, negative 3i. Positive 9i squared. When I see that I squared, I cross it off and do what? Change the sign. Guys, do my 12i's cancel? No. Don't just cross them off because they look the same. They are both negative, so you can combine them. But I have not 16 minus 9, which is 7. And then negative 12i, negative 12i. Negative 24i. Perfect. Can I write the negative 24i first? No. You absolutely cannot. WebAssign might want 7 over 25 minus 24i over 25. We are fine on your test or quiz to leave it like that. All right, that's it. We're done.